This is the spec for the module on what the SAT writers call unsolvable equations. We might want to call it evaluating expressions with unsolved for variables. All of these are kind of convoluted statements. I'll leave it up to you to think of a better name. Evaluating expressions with unsolved for variables. And that's a little bit too long-winded for the name of its modules. Unsolvable equations, I don't think gives the right sense of it. So whatever you want to, you could call it just unsolved for variables or unknown variables, whatever you want to do it. But the types of problems are actually pretty straightforward. It's kind of the classic SAT problem that you'll see in the first 10 or 15 problems of the SAT, where it would be something like a plus b is equal to 5. What is 2a plus 2b? What is 2a plus 2b? And we could say if, maybe I'll write it if a plus b is equal to 5, what is 2a plus 2b? And if the students click hint the first time, you would just write, the first hint would be 2a plus 2b is equal to 2 times a plus b. They click hint again, we know that a plus b is equal to 5. I'll put the parentheses there so they know to put it there. So we could say, so the next hint, 2a plus 2b is equal to 2 times 5, which is equal to 10. So that would be one variation. We could make it a little bit more complicated. This would maybe be the most straightforward. You can mess with the variables, make it a plus b, b plus a. You could make it x plus y, different variables so that students don't see, aren't always able to solve it. I think if we put probably 4 or 5 types of these, and if we change the numbers up and we've changed the variable, so you'd want to change the 5 and the 2 each time, so it always doesn't look completely identical. So we'd have that type. We could also have the type if a plus b is equal to 7 and c minus d is equal to, I don't know, 8, what is, and we could put some type of an interesting statement over here. What is 2, let me write it this way. What is, I don't know, 4a plus 3c plus or minus 3d plus 4b. And once again, when the student clicks the hint, we could say, well, let's just rearrange it. So this is equal to 4a plus 4b plus 3c minus 3d. The click hint again, that's equal to 4 times a plus b plus 3 times c minus d, which is equal to 4 times 7 plus 3 times 8, which is equal to 28 plus 24, which is equal to, what is that equal to? 52. And obviously, you put a bunch of choices that would be appropriate. So that would be the second type of problem. This one is obviously a little bit more convoluted in this case. And then we could even do things where we ask the students to solve for things. So say we had a situation where we tell the student that y minus z is equal to 10. Y minus z is equal to 10. Solve for, and we can say if y minus z is equal to 10, solve for x. And then we have an equation here where it could be x minus y plus z is equal to 2y minus 2z. And at first the student says, gee, I have no idea how to do this. But then you can just separate out the y minus z. So you could say that this is equal to, when they click hint, x minus y minus z is equal to 2 times y minus z. We know y minus z is 10, so we get x minus 10 is equal to 2 times 10. And then we get x minus 10 is equal to 20. And then we get x is equal to 30. So that's the third type. And then the fourth type, and in general, we want sometimes want an a and a b, a c and a d, a y and a z, just so we get some variety in the letters. And of course, we want to change up the numbers as well. We just want to make students not be daunted when they see something like this. That they say, hey, maybe there's a way to solve it. And obviously, while they're doing this module, they're always going to know that, hey, I just have to separate the y minus z terms and substitute them with 10. So let's do one more. Let's do one more. Let's say you have a if a plus b plus c is equal to 6, what is 4a plus 4b plus 4c minus a minus b minus c? And once again, first hint, this is equal to 4 times a plus b plus c minus a plus b plus c, which is equal to 4 times 6 minus 6 is equal to 24 minus 6, which is equal to 18. That's one way we could have explained it. Or, actually, another way we could have explained it, we could have just said, and it's up to you as the module writer how you want to explain it. You could say, and this actually might be the more obvious way, this is equal to, you add the like terms. So 4a minus a is 3a plus 3b plus 3c, which is equal to 3 times a plus b plus c, which is equal to 3 times 6, which is equal to 18. Either of those work, and you don't have to write it in blue like this. I just felt like writing in blue. But whatever you think is appropriate to make it a little bit more understandable. And once again, I'll leave it up for you to name it. I don't know what you would call this. This is solving, I guess, evaluating expressions with unknown variables. I don't know. Or maybe just call it unknown variables. That might be the shortest, most concise way to give this module a title.